All right, so we took our graph of our sine function. We reflect it in the line y equals x. We got this cool looking vertical version of our sine graph. And now we have restricted the domain now down to make it a function. Okay, and we should have known this was coming again. The sine function is not one-to-one. It does pass the vertical line test. The sine function is a function, but it's not one-to-one. It fails the horizontal line test. We've sort of seen this coming, that when we reflect it and it becomes vertical, that would not be a function. So we've restricted it down. So what are the domain and range? Well, our domain, okay, now thinking about reminders of inverses here, if x's and y's switch, domain and ranges switch. However, we had to be careful about that to make this a function. So look at our graph here. What is our domain? What x values are we graphing from? -1 to 1. Okay, which was the range of the sine function. That's inclusive -1 to 1. Now our range, well, the domain of the sine function was all real numbers. However, that can't become the range. We've restricted it down to what? Okay, what is this y value? What is that y value? Well, this y value, okay, came from reflecting this point, which had an x value of pi over 2. This point is 1 comma pi over 2. And this point is -1, negative pi over 2. So our range is negative pi over 2 to pi over 2. Okay. So let's go back to our unit circle here for a second. What does that mean for us? Well, if we are going to be looking for angles from negative pi over 2 to pi over 2, where on the unit circle are we going to get our answers for arc sine, those angles? It's going to be this part right here. There we go. It's the right half of our circle is where we look for to find values of arc sine. All right, so there's arc sine. How about arc cosine? Okay, let's go back to Desmos here. And let's graph the cosine function. Okay. Looks like that. Now we know when we reflect this, we're going to get something similar to what we saw with the sine, except it's going to be just translated up or down by pi over 2, just like cosine and sine are translated left and right by pi over 2. Now, one way for me to get that full graph and not restrict it down would be to type in, well, if this was y equals the cosine of x and we switch the x and y and we say x equals the cosine of y, it gives me this full graph because I didn't write this as a function. So it's graphing, come on lights, it's graphing the whole thing. So now let's think about with this graph, how we're going to restrict this down so that it becomes a function. Okay, where are we going to draw our lines? Okay. Well, for sine, we did negative pi over 2 to pi over 2. Now, where do we see those on our graph here? Well, negative pi over 2 is right here, and pi over 2 is right there. Does this portion of the green curve pass the vertical line test? Is that a function? No, it's not. Okay, we've got to find a different way to restrict it down. And the way we're going to restrict it down is we're going to go from 0 up to here. Okay, and we're going to look at this part of the graph like so. That part is actually a function. So what y values did we restrict it down? This is obviously 0. What value is this one right here? Okay, well, this corresponds with that point right there, okay, which would be at pi. So if we go here and now I get rid of that full graph and I actually type in f of x equals the arc cosine of x, we can see that it's graphing from 0 up to pi. All right, so here we are. Our domain. Okay, let's go back for a second here. Where is it? What's our domain for cosine? What x values are we looking at? What's the x value here? What's the x value right there? Well, this is the point, -1 pi. This is the point 1, 0. We're going -1 to 1, and that makes sense. That was the range of cosine, was -1 to 1. So that becomes the domain of arc cosine. Now the range, we said we restricted down to 0 to pi. So now go back to that unit circle. Where did I put that unit circle? Here it is. Where on the unit circle do we look for arc cosine? Well, we look from 0 to pi, which is the top half of our circle. So arc cosine, we look only at the right half of the circle. Or arc sine, we look at only the right half of the circle. Arc cosine, we look at the top half of the circle. And I would suggest, if you haven't done so already, get out your unit circles, and I would figure out a way to maybe color code it kind of like I am, showing that arc sine is the right half of the circle, arc cosine's the top half of the circle. All right, so we have one more to go here. We need to look at arc tangent. So let's head to Desmos. Let's graph first the tangent of x. Whoops, that's the tangent of x squared. That's kind of a cool looking graph. Check that out. Whoops, there it is. Kind of neat. Didn't mean to do that. All right, there is the tangent. Now, what's going to happen when we switch the x's and the y's and we reflect it over the line y equals x? So I'm going to type in x equals the tangent of y. Yeah, looks like that. Kind of interesting, isn't it? Clearly, this fails the vertical line test. Okay, how are we going to restrict this one down? This one, I think, is a little bit more obvious. Okay? If we want this to be a function, if we just take only this curve and get rid of the rest, we would have it. So how are we restricting this down? What's the y value here at the bottom and the y value there at the top? Let's see if I can't take a picture of this and draw onto it. Okay. So we are looking to restrict it here and there. Now when we look at those, notice when we reflect those become this and that, which are the vertical asymptotes of our tangent function, which happened where? This is at -pi/2, and this is at pi/2. Those are the vertical asymptotes of just one period of pi. So that actually becomes the restrictions for the arc tangent. So if we come back here, and now I type in my function as the arc tangent of x, okay, we only get from -pi/2 up to pi/2. I'll just type those in just so we can see those asymptotes. -pi/2 to pi/2. There we go. That's arc tangent. So let's make some notes on that. Where are we? Here we go. Domain. Domain for arc tangent. All real numbers, right? Wasn't that the range of tangent? range, y values, all real numbers. So the domain for arctangent is going to be all real numbers. Its range now we have restricted to, oh, now this one we have to be careful about. I almost made a mistake here. Maybe you already have caught it. My mistake was to put brackets here, but these are actually, as we graphed them right here, these are actually vertical or horizontal asymptotes. We can't ever get to negative pi over 2 or to pi over 2. So I do have to switch these to be parentheses so we don't include those. I had one more comment to make about this with the tangent. What was it going to be? Oh yeah, we got to go back to our unit circle, don't we? Okay. So arc sine is right half of the unit circle. Arc cosine is top half of the unit circle. Where is arc tangent? Arc tangent is also then from negative pi over 2 to pi over 2. It is also the right half of your unit circle. You just have to remember not to include negative pi over 2 and pi over 2. All right, so now that we have this, let's see if we can find some angles here. What is the arc sine, the inverse sine? We're using the -1 notation here from where I grabbed these problems. What is the arc sine of 1/2? So I go to my unit circle. I want the angle whose sine is 1/2. I know I'm restricted to the right half of the circle. It happens right here, which is at pi over 6. How about the arc sine of -√2 over 2? So I go back to my unit circle. We're finding the arc sine of -√2 over 2. Now it happens on the unit circle here. It happens here. But we know we have to be on the right side of the unit circle. Now a common mistake is to do this. Well, there's -√2 over 2, so it's 7 pi over 4. However, what is the range? Okay, for arc sine, it's negative pi over 2 to pi over 2. 7 pi over 4 is not in there. We have to write it instead as its negative coterminal angle, which would be what? Negative pi over 4 is the same as 7 pi over 4. All right, so just be careful. We might want to use something like 7 pi over 4, but that's not in the range. Arc cosine of -√3 over 2. Arc cosine, so I know I'm on the top half of the unit circle of -√3 over 2. That happens right here, which is at 5 pi over 6. 5 pi over 6 is part of the, is within the range of arc cosine, so that would be 5 pi over 6. Inverse tangent of 1. Where is the tangent equal to 1? We know that we're restricted to the right half, and that's going to happen right here, which is at pi over 4. Now, if I asked for the inverse tangent of -1, that would be down here again. However, are we going to give 7 pi over 4 as our answer? Not for arctangent. It's got to be negative pi over 2 to pi over 2. So that would have to be negative pi over 4. All right, so just be careful. Make sure that you're on the right part of the circle, that your angles are appropriate for arc sine and arc tangent. It's negative pi over 2 to pi over 2 for arc cosine, 0 to pi. Thanks for tuning in. We got more to learn on inverses tangents in our next video.